In this, the third in a series of training videos, we're going to continue looking at how to install this Smart Pro EV charger from INDRA. And we're going to look in depth at connecting and commissioning the charger. Now, at this point, it's really important to note that this is a training video for experienced, qualified electricians. It's not a DIY video for homeowners. This is a complex and potentially dangerous area of electrical installation, requiring the use of calibrated test equipment, and it's not something that should be undertaken by amateurs. In previous videos, we looked at some installation pointers for your INDRA Smart Pro EV charger, and we took a deep dive into the regs regarding earthing arrangements and how the charger can be set up to comply with different situations. So if you haven't already done so, please do go and watch those two videos because they contain critical information for your install. So your charger is unboxed and mounted, and you've checked out your incoming supply and where the charger will be fed from. Let's think now about the type of cable that we're going to feed it with. Of course, it's critical these days, especially where the OZEV grant is concerned, that EV chargers are connected to the internet. So as well as a power supply, we may also need to think about a data cable. Now there's a couple of different options here. If you're in an area where the mobile phone network is strong and reliable, then you can use the 4G dongle provided by INDRA to make that connection to the internet. Installing this dongle couldn't be easier. All you need to do is connect the provided USB extension lead into the USB connection, and you'll find that on the PCB right here. And at this point, you want to take real care to make sure that you don't knock and damage any of the delicate components on the PCB, and also make sure that you get the right angle bend of the extension lead the right way round. And that's going to make your life much easier when it comes to routing that cable into its final resting position. Then connect the other end of the extension lead to the dongle, like so, and then you're going to cable tie the USB socket onto the cable tie mount, like so. So just pop that on the back and then insert the cable tie like so and pull that up nice and tight there. So we pop that onto the socket of the USB, not onto the dongle. And then it's just a matter of peeling off the backing on there and then inserting this up into the top left-hand corner so it sits nice and neatly and tidily out of the way. And then we'll just keep that cable mounted over onto the right-hand side here to prevent that from getting any damage when we put the lid back in a moment. And that's your 4G internet connection installed. However, if the signal in the installation area is a little bit patchy and unreliable, then you may want to think about a hardwired connection. And again, there's a couple of ways that you could do this. You could install a standalone data cable from the charger to the router and then make the end off into an Ethernet plug, which then simply connects to the top of the little PCB here where we saw the 4G dongle a moment ago. Of course, you could run a pre-terminated patch lead in for this purpose. However, you'd need to cut the plug off and then reconnect either in the charger or possibly within the property near the router. Either way, using jelly crimps will help you to maintain a good connection for the data cable, and we'll demonstrate how to use those a little bit later in the video. However, there is another way of getting the data cable to this unit which reduces the number of holes that you'd have to drill through the base of it, and that reduces the chances of moisture ingress. And that is to use a combined power and data cable, such as this EV Ultra from Doncaster Cables, which has been designed with pretty much this exact application in mind. It comes in either 3-core or 5-core for single and 3-phase supplies, and a choice of either a 2-core data cable, perfect if you're using the 4G dongle and only need a connection to the current transformer at the origin, or, as we're going to demonstrate in this case, incorporating an 8-core data cable, which we can use to make both an internet connection and connect the current transformer. The first step is just to run the EV Ultra cable from the location of the charger to the consumer unit that we're going to use to supply the circuit. At the charger, if we look at the underside of here, you can see that there's these dimples that act as drilling guides for bringing various cables in. The top left dimple is the one that we need to drill to bring the mains cable through the enclosure in the correct position. So let's do that now. Then we need to install a stuffing gland to help maintain the correct IP rating of the enclosure, and then we'll bring the cable through there. We're using this special gland here from ILECTRICIANS, which only requires access to one side of the enclosure, which can be super helpful in certain circumstances. A little bit unusual in that the lock nut is on the outside of the gland and not the inside, but as you can see, once that's done up nice and tight, that's going to seal against that and maintain that all-important IP rating. Excellent, so now that's in, we can bring the cable in and have a look at making the connections. We'd recommend making the CT connection first. This is simply done by taking the blue twisted pair from the Cat5 cable, and in this IDC terminal you can see back here there's a terminal marked BE and one marked BE/WE. So we're going to connect the blue conductor into the terminal marked BE, and the blue and white conductor into the terminal marked BE/WE. So we'll just get those into place, and then using a punch down tool, we simply connect those in nice and easily, like so. Then while we're dealing with the data cable, we can make the hardwired internet connection by connecting the remaining conductors into a data plug using your preferred crimping tool for this, and then plugging it into the data socket at the top of this small PCB here. Now it's really important that we get these in the right order, so looking at this from the top down effectively, we've got here the brown, and then the brown and white, the green, and then we missed two conductors, and then we put in the green and white, the orange and the orange and white. And it's really important we get those in the right order, and also that we leave those two connections in the middle there left without the blue conductors, and we need to make sure that we miss those out. So we'll just spin this around a little bit, and then we'll use the crimping tool in order to just make that nice and secure. There we go. And that's our connection made, and it's just then a matter of popping it into the top of the data port on the top there. There we go, that's our internet connection sorted. The reason that we can use the blue conductors for the current transformer and not the internet connection is that the type of connection that this charger relies on doesn't use 2 of the 4 pairs in the data cable, which is handy to know. So having made the current transformer connection and the internet connection, we can now have a look at the mains connection. This is super easy because the charger incorporates these Vargo lever style connectors, so it's just a matter of trimming the conductors to the right length, leaving a little slack for the next electrician, and also for the ease of your own installation, popping the conductor into the terminal and then moving the lever down to the terminated position. So I'm sure you'll agree that that's really, really nice and straightforward. At this point, it's also good to make absolutely sure that you've got the conductors into the correct terminals. The line and neutral terminals are obviously pretty straightforward, but then there's the terminals marked REF-E and CPC. Now the CPC terminal is where you'll connect your incoming CPC from the supply cable that you've installed. So that's going to go inside there, just exactly the same as the line and the neutral conductor. However, the REF-E terminal will be used if you're installing a reference earth electrode. If you are, then it's recommended that you use a 4mm or 6mm squared solar cable like those used for connecting photovoltaic panels together. This will be run out to the position of the reference earth electrode and connected to the rod in the usual way. At the charger, you'll want to bring that through a hole drilled in the top middle dimple, and again using an appropriately sized stuffing gland to provide cable retention and protection against the ingress of moisture. When connecting this into the relevant terminal, INDRA recommend the use of a ferrule crimp on the end of the solar cable there, and bear in mind that this earth electrode connection is to give a reference value to earth for the charger only. It's not relying on it as the fault path for the charger. At this point, it would also be a good idea to make sure the mode switch in the back of the charger is on the correct setting for the type of protection you've installed. If you're not sure about these settings or whether you should be using an earth reference electrode or not, then please check out the previous videos in this series, as it's critical you understand the various options available to you with this charger. Once you've made all the connections to the charger, you'll need to replace the cover. Another important point to observe at this stage is that the screws on the lid of the charger will need doing up to the correct torque setting. Failure to do this could lead to the ingress of moisture and the failure of the unit. So a setting of 2 Newton meters for the cover screws is required. So we've set the torque screwdriver to the correct value. So now we can do the screws up until the screwdriver clicks on each one, and then we'll be all good. So I'll get the lid round from there, and we'll pop that back, making sure that we're not obviously compressing any cables or causing any damage in the back there. And then it's just a matter of popping the screws in one at a time. So we'll just demonstrate one so we know what it looks like when the torque screwdriver is at the correct setting. So we'll pop that one in there, we'll get that doing up. And then once it reaches the correct level of torque, the screwdriver will go tight, and then it will click, and that's it. So that's now been done to the correct setting. I'll put the other 5 in, and then we'll put the rest of the cover on. Then the cover simply clips into place, and there's 2 security torque screws on the bottom here, and they do up to a torque setting of 1 Newton meter each. So once we've done that, the charger's all installed, and then we can go and have a look at the other end of the cable. So the mains connection is straightforward. We've just taken them straight into the RCBO that we selected in the first video in this series. And then the data cable, we've diverted down to this back box that I've mounted underneath the consumer unit. And from there, I've taken a data cable down to the incoming supply position where we installed the current transformer in the first video. Now at the back box, what we're going to do is we're going to connect the blue twisted pair from the EV Ultra cable to the blue twisted pair in the cable to the current transformer. And we're going to do that using gel connectors. So these are really good because you don't need to do any stripping and they make a really good permanent connection. So we'll just connect the two blue and white conductors together. So we just push them in until they reach the far side, and then we just squeeze down the top of that. And that is those connected. There we go. Make sure you push it down really firmly. And then we'll connect out the blue cores. So again, push them in as far as they'll go, and then give them a really good squeeze. And that will make the connection for you. There we go. So they're now connected through. That's our current transformer connection made, and we can just tuck that in the back of the box there. Now what we're going to do next is we're going to install the data cable front onto here. So we're going to put the data socket onto the front of here. So using the remaining cores that come from the EV charge point, we're going to connect those into the back of here using a punch down tool in the normal method. So we'll get that on and then we'll flip back to the other camera. Then at the current transformer position, we'll pop another data plug on the end of the cable and connect it to the current transformer. Now all we've got to do is finalize the internet connection. It'd be great if the router for the property just happened to be in this position because we could just use a patch lead to join the data point to the router. But as is so often the case, it just isn't. So again, we could take a standalone cable to the router, pop a data plug on either end and connect it to the router and our data socket. Or if it's a bit of a stretch to run a cable to the router, and let's face it, they're not always in the most easily accessible positions for a cable, this EV charger will actually operate with a power line adapter. Now this is a piece of kit that will actually transmit your internet connection over the mains cables in your property. So if you have a socket outlet in the region of the consumer unit, you can simply plug a power line adapter into the socket outlet at the consumer unit and another one where you've got your router plugged in, and then connect the router to the adapter via a patch lead, and then connect your EV data point here to the adapter at this end, like so. And the internet connection will now pass along the mains cable, joining those two adapters together. And there you go, you've got an internet connection. Obviously there's a few different ways of achieving these connections, but we think this is the best overall balance between ease of install and minimal disruption to the property. Once the circuit is installed and the usual dead tests have been carried out, you'll need to check that the EV charge point behaves as it would when an EV is connected for charging and under certain conditions. This is achieved by connecting an EV test adapter and checking how the charger responds. Basically, we're fooling the charger into thinking that an EV is connected. Plugging in the adapter, we start by setting the PP dial to the correct charging level. For a domestic installation, this is likely to be 32 amps unless it's been set to a lower value due to the nature of the incoming supply size or other restraints. Then with the CP dial in position A, the charger shouldn't register any connection to an EV. We've then got two options for the next step, and the way we twist the dial depends on the type of charger that we're testing, whether it is an actively vented system or not. Now the INDRA Smart Pro doesn't employ active venting, and so we'll set the dial to B on the unvented side, and this is now simulating an EV being plugged in but not charging. And at this point the charger should lock the plug into place, and as you can see that can't be removed now, and the indicator on the charger here isn't showing any charging process. Now moving the CP dial to C, we're simulating a charging EV, and the charger has changed its status to charging, and that's verified on the EV test adapter by illuminating this LED here. Now when we move the CP dial to position E, or press the button marked E depending on the tester that we're using, this is simulating a fault with the electric vehicle, and it should cause the charger to see that fault and disconnect the supply to the EV, or in this case the test adapter. And then we can see that that's worked nicely. Next, you'd move on to the usual live tests for a new circuit, and to make these tests as safe as possible, you can again use the test adapter to make a safe and easy connection to the live conductors, just making sure that the CP dial is set to position C for this, so that the EV charger connects the socket outlet to the supply. Now we've completed the testing for this charger, we're going to look at the commissioning procedure with the app. Now the first thing to bear in mind is that the app is not downloaded by visiting the App Store or the Play Store as you might expect, but rather by contacting INDRA and requesting access to it. This is because INDRA are currently very focused on building partnerships with installers rather than just releasing their chargers onto the wholesale market for just anyone to install. This means that if you're installing a charger, then the work should have been pre-arranged and scheduled with information such as a customer name and address. And this is really important, as you'll see in a moment. You'll be able to access the relevant pages for commissioning. First of all, you need to access the Find a Customer homepage and then enter their last name and postcode of the installation. The relevant customer information should then appear and you can select Continue. If the search is blank, then double check that the information has been correctly entered, and if it's still blank, then contact whoever scheduled the job for you, and this person will be able to add the new customer to the system. Obviously, if you're working for yourself, then you can be set up with the necessary permissions to add a new customer yourself. Once you've found the correct details and click Continue, you'll be able to add a charger. This is most easily done by scanning the QR code on the side of the charger, and this is the smaller one that's on the same label as the MAC address. If for any reason the camera on your device isn't working or it doesn't have a camera, you can always enter the MAC address manually by clicking here. Scanning the QR code or entering the MAC address will validate the ID format. Check the device has been pre-registered and check that the device is not currently associated with another account. This can happen if the charger has been recycled from an old customer account. Once these checks have been done and all the boxes are showing a tick, you can click Continue to move on to the next stage. Now this is to set the maximum house load. Depending on both the DNO fuse rating and what you've stated the maximum demand to be in the paperwork you've submitted to the DNO, you'll assign the relevant value. If you're not sure what the fuse rating is, you should select the 60 amp value to avoid blowing the main incoming fuse. Next, you can enter the vehicle information. This is really important for maximising the benefits of the smart features in the charger, such as ready buy times and scheduling. So add the make, the model and the battery capacity. And if the battery capacity isn't listed, you can add it in manually. If the homeowner doesn't have an EV yet or isn't sure of the details, they must be reminded on handover to add the information in the customer app. At this stage, you can also access confirmation that the charger and attached devices are performing as expected. This is in the telemetry section, as you can see here. Once you've been through this procedure, you will get a commission summary. If the details are all correct, you can mark the job complete, and if anything needs changing on this page, you can do so by clicking the Edit button next to each section. Now, before we hit complete on the commissioning process, there's one more thing we need to do, and that is to calibrate the current transformers. Now, this is absolutely critical if load curtailment has been applied or if there is micro generation being used. There's 3 different ways that it can be done, and we're going to demonstrate dynamic load calibration and fixed load calibration in this video. For dynamic load calibration, you'll need an electric vehicle with the battery charge lower than 90%. After confirming that calibration is required on the app, you'll need to plug the EV in. At the same time, you'll need to connect a clamp meter around the incoming supply where the current transformer sits and take a reading from there. Then, once the charger has completed its calibration process, you'll be prompted to enter the value from the clamp meter. The app will then confirm that the internal power readings are within 5% of the manual reading. If this is achieved, the app will give you a summary of the calibration process. If not, you may want to check it again a couple of times, and if it's still not getting under 5%, you'll need to check your CT connections along the run of the cable and make any improvements you can. If you don't have an EV to hand, then you'll need to use a slightly different method called fixed load calibration. For this method, you'll need a fixed known load, such as a kettle or a heater, rated at least 2 kilowatts. I'm going to be using this 2 kilowatt space heater for my test. For this one, you need to disconnect all of the loads in the house, with the possible exception of the router if you're relying on it for your internet connection. Plug your fixed load to the EV adapter, connect your EV test adapter to the charger and the CP dial to A or B, so no load is being applied. Then press and hold the boost button on the charger until it's beeped 6 times. This is how you trigger the fixed load calibration process. Now release the button and wait for a minimum of 30 seconds, then switch the CP dial to C to connect the supply to the socket outlet, wait another 30 seconds and then check the percentage difference. From here, there's 3 outcomes. If the reading is below 5% difference, all is well and the charger can be put into service. If the reading is between 5 and 50%, then the charger will rely on calibration post-commissioning. This happens automatically at a time that is unlikely to disrupt the homeowner and will happen within 3 weeks of completing commissioning. But you must point out to the customer that until this has happened, they may encounter some small errors when using some of the smart features in the charger, and the data from the charger may not be fully accurate. If the calibration result is over 50%, then this should trigger you to check out the cabling and connections to the current transformer to bring the value down to at least below 50%, but preferably below 5%. Once the commissioning and calibration process is completed, the customer will receive a welcome email that will give them access to the customer app, giving them information about and control over their charger. And there you go, that's the connection and commissioning of your INDRA Smart Pro charger complete and ready to hand over to the customer. In the fourth and final video in this series, we'll be looking at some frequently asked questions and troubleshooting for your charger. All that remains in this video is to say thank you very much for watching.